instruction, data, ChatGPT, and mathematics. Oh my. This is a conversation that I just had this past week at the California Assessment Conference, but I'm going to show it slightly different. And as I do that, I'm going to copy it and send it to a few friends because they're always telling me I never know when you go live. So I'm sending it now for those of you that are like, yeah, let me know. And as I send that, no reason to send a test email. Let's just send it. What are your thoughts about using data to inform instruction as an instructional leader, an academic coach, a teacher, a principal, or an assistant principal? The reason why I'm talking about this is because mathematics in the state of California has taken a little bit of a either flatlined, may have slightly increased, but we're not where we want to be. And so I want to show you what I'm talking about. In the state of California, we have something called the assessment, the Smarter Balance Assessment. These are the summative assessments for ELA and mathematics. What does this mean? This means this is where we are as a state in mathematics. So if you take a look at this, you can see that we have that 35.54% of our students in the state of California have met or exceeded the state standards in mathematics. So that basically means that if you take the opposite of that, 100 minus 35, just under 65% of our students are not meeting the standards for mathematics. So we have 23.991% that are close. They're like almost there. And then we have 40.55% of our students that haven't met at all. So there is a huge discrepancy. And I guess I would say, what does that really mean when we look at mathematics? And there's another part. We typically stop as leaders at school sites and sometimes even in districts, not all. We stop here and we go, what are we going to do now? But there's more data to be had or looked at and have conversations with. And it's, if you click on this, the state of California gives you all of the data here, the donut before, but now it's broken up by grade level. You can see the overall here. That's what you saw on the first page. And then you get the data in numeric form by grade level. And then you have now composite area claims. What does this mean? It means that we have concepts and procedures. This is how students can calculate, read formulas, do mathematical concepts, meaning they can analyze a formula and solve for something. And then we have the mathematical practices. This is how students think about the math. Can they look at a graph and tell you what it is? That's what that means. And forgive me, I do want to send one more. I need to send one more email out. So there we go. Save and exit and send. Okay, yay. So this is where we are. This is what happens by grade level. And concepts and procedures, how well did students apply mathematical concepts and procedures to solve problems? Like I said, to be able to compute, solve problems, come up with some type of answer. It could be the sum, the product, it could be a comparison. And then mathematical practices. How well do students apply strategies to solve complex problems and explain the reasoning for solutions? And some of you are thinking, but what about the area claims? Did they keep that? Well, yes, they did. A little bit more colorful. The concepts and procedures are still the same. Same thing up here. The difference is they took all of the mathematical practices. These are the mathematical practices: problem solving and modeling and data analysis and communicating and reasoning. They took all of this data and put it together here and told us this is the thinking behind the math. This is where we want students to process through the math. So what does this mean? And you're thinking, yeah, a lot of numbers. I see that. We have above standard, near standard, below standards for the concepts and procedures. And then for problem solving and modeling and data analysis, same thing. So these are how students are doing with this standard. And there are standards within the concepts and procedures. Like whatever state you're in, every state has standards that students are to master by grade level. And I want to show you what this looks like. Now, before I do that, for fun, I took all of the performance area claims and put all of the above standards together. So if you're thinking, I don't remember, let's go back. So we have concepts and procedures, purple, problem solving and data analysis, and then communicating and reasoning. So I grabbed all three of the above standards and put them in a graph. I'm going to put this here so I remember which one it is. So all of the above standards, concepts and procedures, we are pretty rocking it in third grade. I think you would agree. You see that? But by the time we get to fourth grade, fifth grade, sixth grade, seventh grade, eighth grade, you can see that here, and 11th grade, concepts and procedures continually go down. They take a dip. And then we have communicating and reasoning, and you can see the key here. Like whatever is happening in third grade, like kids are really getting this concept. Now I have a theory. Students who, whether they're affluent, economically advantaged, economically disadvantaged, tend to between kinder, first, second, and third grade. Because remember, third grade isn't just assessing third grade. They're assessing everything before that. Same with fourth grade, everything before that and their year, because it builds upon each year. And by the time they get to 11th grade, you're thinking, where's 9th and 10th grade? Well, 11th grade is assessing everything before that too. So what is happening? Like that's where the students are living. They seem to be able to compute at a higher rate than they are when it looks at either communicating and reasoning or problem solving and modeling and data analysis. Again, these are those three areas. But then if we come down here and we look at the near standard, we have a lot of students living in the near standard in the state of California for communicating and reasoning. So I'm wondering, what could we do to bump that into the above standard? And then we have moderately, depending on the grade level, like especially 11th grade, students are able to model and problem solve. So again, we have problem solving and modeling and data analysis. Like by 11th grade, they're living in this area. So how do we push them just a little bit harder to get to the above standard? And then here, concepts and procedures, remember, they're pretty good up here. However, when we come down to below standards, it seems as if you either, as a student, get it. Remember, problem solving, and what does it say in the question? It says solving problems, or they're not getting it in concepts and procedures. And communicating and reasoning, they're living, not very many students here. And even in third grade, there's like really hardly any students that aren't getting it. They're somewhat getting it because they're here in the near standards. The question is what can we do? What can we do to get kids going here? What can we do to get kids into the above standard? Now, if you're a leader, a teacher, and you're thinking, I don't even know, I teach the mathematics, I show them what the formulas, and we're good. I taught it, but the truth is that doesn't mean they get it. That doesn't mean they get it. So what can we do about it? There is something called the Smarter Balance sample items, and I like to browse here. And if you're thinking about, well, where's the link? You could Google sample items, Smarter Balance, and or I'll put it in the description once the video completes. But you can select any grade level here. Any grade level. I'm going to select grade 6. Now, of course, you can do it for ELA, literacy. But for mathematics, here's what I want to show you, because we're going to do some problems, and I'm going to show you how to get kids to think about the math, problem solve, model it, and reason with the mathematics. I'm going to give you some quick tips, and you can use ChatGPT to help you. especially if you're thinking, I don't even know where to start. You can be, and mathematicians, math teachers are really good at getting the mathematics out, like they can talk about it, but we need kids to think mathematically. So I want to click on concepts and procedures. It doesn't matter what grade level I select, the standards, no matter what grade level it is, even high school, third grade, we'll live in sixth grade. All the standards are here. But if I select problem solving and data analysis, problem solving, communicating and reasoning, or modeling and data analysis, notice that they separated these two here. Mathematical practices only. And you're like, oh my gosh, what is that? Like, there's no standard there. If you're in the state of California, we give you these fun things called targets. If you're thinking, what is a target? If you go down to one of these baseball cards or one of these sample problems and you hover over it, there's a verb usually there, like interpret results and in the context of a situation. Like it's telling you to interpret something. And if you click on the problem, it'll tell you what it's looking for. And it's usually not solving a problem. It's asking you to reason and argue the problem. That's where we have kids that somewhat can do this because we know that they live in the near standard area. And again, this data is the same data that I got from here. Okay. And if you're like, oh, I really would love to do those graphs for my school site or district, don't worry. I will put a Google Sheet that you can copy and you can put all your data in here. You can even do it for ELA for that matter. So we're going to live here for a moment and we're going to grab one of the sample problems. And we're going to grab one of the sample problems and we're going to throw it into ChatGPT. But before I do that, I want to show you something. There is a book called Routines for Reasoning, and they created like an umbrella model of looking at all the mathematical practices. If you're not sure what the mathematical practices are, National Council of Teachers of Mathematics developed these mathematical practices in like 2010 is when they published them. They always were talking about communicating and reasoning and problem solving, but they came up with these 8 mathematical practices and they organize them. And typically we see these 8 mathematical practices, and I probably should have had this, but I'm going to show you for the state of California. Like these are our mathematics. This is our framework for the standards, and they live here. And sometimes you look at this and you're like, no one leans to the left to look at this, but it does have the number 1 here, and it gives you these 8 other ones. But if you go to any grade level for mathematics, the mathematical practices live here. They live on the right side, and they kind of are just there. Depending on what grade level you teach, you get all of the standards, but these tend to get forgotten about. So what I want to show you just quickly, and I have a PDF that you can grab afterwards. It'll be in the description. You can have it. Just fill out the form. You'll get all of the information. But this is where I want you to just give me a couple minutes to explain this. Any student, this is like the overarching theme of mathematics. Make sense of problems and persevere in solving them. If kids can't make sense of the problem and actually have some gusto and persevere through it, they're not going to be able to move forward in mathematics. So this is what I want you to see. And then we have quantities and relations. So think of this as like an avenue of thinking, okay? Reason abstractly and quantitatively. And then we have another avenue. So this is MP2, this is MP7, mathematics practice 7. Structure, look for and make sense of structure. And then a third avenue, repetition, look for and express regularity in repeated reasoning. What I want to say about this is that these 3 areas are paths that teachers and students can choose to work on a mathematical problem. These 3 areas. You can choose one. Now, as a teacher, you should teach all of these, but these are like lead actors. No matter what, you're going to reason abstractly and quantitatively, you're going to look for and make use of structure, or or you're going to look for and express regularity in repeated reasoning. Now, I showed you that we have all 8 of these. So I said 1, you have to do. If you can't do 1, you can't do anything else. Then students can choose 2, 7, or 8. As teachers, we do need to teach all of these. And you can teach them probably doing the same math problem over time. So, oh, I did not mean to close that, but that's okay. So we have these, and now we have 3, 4, 5, 6. So I want you to look at this just for a moment and process through that. When you're looking at these, you can see that you have construct a viable argument, you have model with mathematics, and you have use appropriate tools strategically and attend to precision. I would argue that you would want to attend to precision no matter what. So I'd almost want to say, no matter what you're doing, you will always want to attend to precision. So even if you're thinking, well, I'm not quite sure if students can attend to precision as a teacher, even when you write on the board, you know, if you're all over the board, are you attending to precision? So you can practice what that looks like. Now I'm looking for that other diagram quickly because I closed it out. Let's see. Give me a moment. I have it. I promised I have, here it is. Okay, because I closed it. I don't want to close it. So you have the lead actors. You have to do number 1. These are avenues of thinking. And then those other 4, you should teach these separately, because sometimes you'll use all of them, sometimes you'll use one of them. And again, you choose 2, 7, or 8, and then you have navigating the problem solving process. So you're either going to construct a viable argument or critique the reasoning of others, like let students talk to each other about the math, model with mathematics, use appropriate tools, whether they're math manipulatives, if it's a graph, like for example, this is a tool, it's a graph, and then always attend to precision. If you are not elementary add-ins, adding 2-digit numbers to come up with a sum, if those 2 digit numbers or 3-digit numbers aren't lined up, kids are going to get the wrong answer because they're not attending to precision. And that's just kind of a small, just an easier way to think of it. So here's what we're going to do. We're going to grab one of these math problems and let's kind of choose an easy one. And to grab it, I'm going to minimize it slightly. And I'm going to take a picture of it because I want to see, so you can see how could you teach this as a teacher. So in ChatGPT, especially if you're an elementary teacher and you're like, this is not my area of expertise, but I want to be able to do this. So I'm uploading this math problem, okay? And now I'm going to say, and I do have all of this information. So I'm going to go to this one. I'm going to say, I would like to discuss this problem with my students. How can I choose always MP1? Let's choose MP2 to start learning about the mathematical practices. Now, I already showed you that MP2 is reason abstractly and quantitatively. Okay. So let's see what ChatGPT has to say. So to guide students through this problem using mathematics practice 1, make sense of the problem and persevere in solving them, and then reason abstractly and quantitatively. First, we have to understand the problem. Start by discussing the context of the problem. So if we go and look at this problem, it says Jeremiah planted tulips and lilies in a field with a width of 5.5 meters. The field of flowers is shown. So here's the field of flowers. Okay. Then it says, so it repeated the question. And it says Jeremiah is planting tulips and lilies in a field, and we need to find the total area. So it goes through, like, identify each equation that could be used to find the area in square meters of the field of flowers for the length X in meters. So break it down. Help students break down the problem in smaller, more manageable parts. Ask them, what is the total length of the field? Okay. So we're making sense of the problem first. Like, I would be looking at this problem and trying and making sense of it. So the total length of the field, it told you the total length of the field. So you might need to have some context. You might need to have area. You might, making sense of the problem. Never mind. I don't even need to. How do you calculate the area of the rectangle? So it's telling you, let's make sense of this. I really like that. Encourage perseverance. Encourage students to keep trying different approaches, even if they get stuck, and validate their efforts in productive struggle as they explore various solutions. So I like the word productive struggle. It's like ChatGPT knows me now. Then reason abstractly, contextualizing and decontextualizing. Love this. Students can translate the real world problem into a mathematic expression. They know the area formula for each section. Now, there's an assumption there that you already taught this. We are totally okay with that. We're just going to be okay with it. We're going with it, okay? So, tulips, we know the tulips area is 2 by 5.5. We see that. The tulips area is 2 by 5.5 because even 5.5 meters, and if you're thinking, why didn't they use the M? We might have to ask ChatGPT that because this is 5.5 as well, okay? And then the total area, 5.5 times 2 plus X, and then the lilies area is X plus 5.55, which simplifies the abstract equation A equals 5.5 times X plus 2. Now, I would say, can we reason abstractly and quantitatively even more? For example, why wasn't the M meters discussed? Now, because it jumps a little bit, like, let's really dive into the math. So now it's saying that the field's width is constant, meaning that no matter how long the section of tulips are, lilies are, the width remains fixed. But what I'm looking for, the total length of the field is 2 meters. Got it. In other words, why didn't we keep the units? Okay. Now, I don't know, this problem is not showing that, but kids will get stuck here. Like, this is a conversation you could have with students, because what's going to happen by keeping the units, we can verify that our calculations make sense. If we are calculating the area, the final unit should be in squared meters. If the units don't match, if we end up with just meters or some combination, we know something went wrong. And now, because I know what answer I'm looking for. Okay. Look at the photo again. I know that I want it to tell me something about why it didn't show me this. The outcome answers don't have meters. Just give me the why and not the formula. Because students are going to want to they're going to want to derive for M. So here it is. This is why. Since the tulip section is a known size, you can easily calculate its area. You know that the area of the tulip section is always 2.55. So let's see. The area of the lily section depends on the length X. So you need to think about how changing X affects the area. Combining the two areas, notice that the tulip section contributes a fixed amount of the total area. So you're being asked which equations match the reasoning. Consider each option and ask yourself, does it represent any calculations? I am asking or stating to you, I don't need to have the units. I wanted to say that. I'm gonna yes or no. So because kids are going to, and that's the question I'm going to say. Students are going to want to use meters. I want to explain to them why we don't have to. That's what I'm looking for. So these are things that we can do as educators to say, we don't need this. We don't need to say that. So here it is. Why we don't always need units to include units. Focus on the mathematical relationship, simplification for clarity, assumed units, avoid confusion. So here's the question. So we know that, and you can do this with any of these mathematical practices here, any of them. So we did it for this one. Now let's say, look for and make sense of structure. Let's now use SMP 7. So you can, as a teacher, you can go through these. Now, if you're a principal and you're like, I wouldn't even know where to start, you can use this as PD to help you. You can get teachers to talk about what does this mean in your content area to look at the mathematical practices. If you do this, I am confident that students will increase their academic success in their thinking in math and the outcome on the status summative assessment. They will do really, really well. Okay, so now it's saying recognize the structure, break the fields into parts, understand the total length structure, understand how the structure relates to the formula, why units aren't necessary. So this time it knows, it's telling me why units aren't necessary, and then pattern recognition. Now, if I go back to the mathematical practices, it's now saying look for and express regularity. So, and if because most of you are really good at mathematics, if you're a teacher in mathematics, and if you're elementary, you're like, this would really help me, because if you did this for third grade, it's not going to look this profound or complicated, but it's going to really help you with helping third, fourth, fifth, and even sixth grade. Now do SMP 8. So as a teacher, you could break this down and use the same problem over a few weeks at the beginning of the school year, or every time you teach a new standard. Because now, here's the thing. So let's just look at this for SMP 8. Okay, look for and express regularity in repeated reasoning. So in this problem, the width of the area is always 5.5 and it multiplies both sections. So repeated reasoning, tulips, the calculation is always. Lilies, the calculation follows the same pattern. The only difference is the unit is different because we're using a variable. And the repeated reasoning, width multiplied by length. That is, so it doesn't matter what avenue students choose, whatever makes them happy. But we have to teach all of our students the avenues of thinking. Now I would say, and maybe we should come back to this in another video, but I would argue, how now could I use, let's say, let's go back to Avenue SMP2. How can I integrate SMP 3, 4, 5, and 6? I would do these separately to teach them, but I'm just showing you that you can say, okay, construct arguments. Ask students to justify why the formula 5.5 x plus times x plus 2 is correctly represents the total area. And then why doesn't this one? Because look at the problem. It gives you all the wrong answers, too. There are two answers. The two answers are this one and this one. Like, it's giving you ways to do it. Now you can model it. Have students activity. Have students sketch their own diagram of a simpler problem with different lengths. I would say I would want them to stick to the same problem for modeling. Because this is new. No need to recreate. So I would want that to happen. It's probably going to recreate it anyway. It's doing it anyway, even though I told it not to, but that's what it's doing. Anyway, so when we're looking at, if you are new to my channel, one of the things that I like to do is look at the standards for mathematical practices. And I use state data. And I went over the claim data. Like I did this for at the California Assessment Conference, and I talked about each claim. And in each claim, these are where all the standards live. But then we have the thinking behind the math. And then I talked about the umbrella model of the mathematical practices according to the National Council of Teachers of Mathematics and the book, Routines for Reasoning. And this is so profound that I believe as educators that if we do this as math teachers, kinder, first, second grade, yeah, you should start this in kinder. And you're thinking, I don't know how to get them to use one of these avenues of thinking, because you only need to use one of these. Remember, I showed you that these are the lead actors. Choose one of the avenues of thinking, teach all of them. And then they should be able to construct an argument, model the math, use appropriate tools, and attend to precision. And I also showed you that for fun, this is how the state of California lists the mathematical practices. And as teachers, we're like, I don't even know where to begin. I know they need to make sense of the problem, and I know they need to attend to precision, but how do I do one of these or all of these? According to National Council of Teachers of Mathematics, this is the best way to look at mathematics. Umbrella model, choose an avenue of thinking, and then get kids to do this. And then what I did is I grabbed this problem. It's a sample problem. It's public information. I grabbed it and threw it into ChatGPT and said, okay, help me. Now, if you're thinking, I just want to focus on third grade. Now, if you're a kinder, first, and second grade teacher, you can use products that you have and take a picture of it and upload it into ChatGPT and say, how can I problem solve and use the mathematical practices. But I just took a screenshot of this. And if I wanted to go back to the sample problems here, and yeah, you could do some of this for ELA, but we're working in math. If I wanted to go back to the sample problems, what's interesting is that this is the one that I chose. And it tells me that actually, it's not necessarily the one that I chose. I think I chose communicating and reasoning. That's right. So I grabbed one of these problems. That's not the one. Now I'm like, which one did I use? But anyway, I grabbed one of these pictures, and that's third grade. That's why. So I grabbed one of the problems, and it's multiple choice. I took a screenshot, threw it into ChatGPT, and said at the very beginning, I uploaded it, and I said, make sense of this problem and persevere through it, and then use reason abstractly. Then I did it for Avenue 7, which again is look for and make sense of structure. Then I did it for repeated reasoning. If you're a principal and you're like, I don't even know how to start with PD, I'll give you all these resources. It's in my description. I talked about it at the California Assessment Conference. This, I think, as teachers or principals, we can change the outcomes of math because the state of California, most of our students that live in the above standard area, when they live here, these are the kids that are doing well. We're good at concepts and procedures. But in the next area, the near standard, if we can bump the kids that are communicating and reasoning, like, and this right here is one of those problems, for example, if we can get kids to think about the math, communicate and reason through it, take a picture of it and have conversations and let them argue it, you would change. First of all, you wouldn't be as exhausted as a teacher. I think it would change what we're doing as at school sites, and our test scores would get better. If you're thinking, well, I wouldn't even know how to make those graphs, don't worry. In the description, you can have this, make a copy of it, and you can put your school data there. It doesn't matter what state you're in. You can create your own graph and throw it into ChatGPT, but you just need to take information. Ask ChatGPT about the problem and say, how can I use this problem? So I do want to go back to third grade because third grade is a fun one to do. If we go to communicating and reasoning, this is third grade. People are like, oh my gosh, that's third grade. Like if we took a picture of this and we threw it into ChatGPT, I'm going to say, let's try a third grade sample item. I'm going to add the photo. I'm going to upload the photo. I took a screenshot of it. I think it's the same one. Yeah. And let's work through SMP 1 and SMP 2. Remember, I am an elementary teacher and need support. My students get the math, but not the thinking. So I'm giving it a prompt. I'm giving it context. I told it what grade. I gave it a picture and it spits it out. So it says, let's walk through. What I like is it gives me markdowns. Let's walk through the how to approach the third grade problem using standards for mathematical practice once, make sense of the problems and persevere and solve them. I told you, if they can't make sense of this problem, they cannot persevere through it. And then reason abstractly. What is happening? So let's just look at the problem. It says right here, Paul made a number line to show the times he started reading and finished reading. Okay. Paul read for 45 minutes. Which number line shows 4 p.m. in the correct place on Paul's number line? Okay. We can see clearly, but as teachers, by the time we do this 3, 5, 6, 7, 8, 9 years in a row, we're good at it, but we're forgetting that students need that same amount of time to get good at it. So Paul is reading from 3:30 p.m. to sometime after. The key detail is that Paul reads for 45 minutes. What are we asked to do? We need to identify which number line correctly shows 4 p.m. on Paul's number line. Start by guiding students to visualize what is going on. Now, I would argue that maybe you have students hold signs up, because that's an analog, man. I mean, that's a digital clock. I almost would want to say, what's an analog clock look like, to really challenge them? And start by guiding students to visualize what does 3:30 p.m. starting time look like, and how long is Paul reading? Like, how long is he reading? How long? And if Paul starts at 3:30, where would 4 p.m. be on the number line? And it breaks it down. So, persevere in finding the solution. Does 4 p.m. come 30 minutes after 3:30 on the number line? And I would even say, can you break this down more? And now I would say, what about, excuse me, SMP 7? Because remember, I told you the avenues of thinking, we have to start here first, 2, 7, or 8. So now we can recognize the structure of the number line, because students only need to choose 2, 7, or 8. We need to teach them all that, but kids will choose the one that they feel most comfortable with. And I think we forget that as teachers, that we tell them one way and they may have many ways to come up with it because their brains are different than ours. So it gives you another, recognize the structure of the number line, um, explain the number line structure, identify the use of the structure to find the correct number line. Option C, the structure of the number line shows why SMP 7 is helpful here, making use of structure, classroom tips for SMP 7. And and if you're still new to it, you can say, I still don't understand. Help me. Now, SMP 8. As an educator, if I had ChatGPT when I was a teacher teaching science, I would be more efficient. I spent hours and weekends creating lessons and reading. And when I was grateful for Google, I mean, now we have ChatGPT. We can become self-directed learners as educators and provide our own professional development using ChatGPT. So now it's telling us, look for and express regularity in repeated reasoning. The repeated reasoning, 15-minute intervals. Oh my gosh. 15-minute intervals. Like we see 3:30 to 4. Now we have 3:30. What is the difference here? Then we have 3:30 here, 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 and here. And then we have 3:30 to 4. Like, how do we know what intervals are right? And if you're thinking, I don't, so more gives you the answer here. Okay, it's the answer key here if you're not sure. And then you could ask ChatGPT and say, well, why is B right? So because and it gives you some keys here. Paul reads for 45 minutes. So if Paul is reading for 45 minutes, why is this right? Why is B correct? Especially if your teacher, like, I don't visually see it either. Sometimes we don't see it, but we're guiding students to get there. So it tells us, here's how to break it down. Paul starts reading at 3:30. This is marked on the far left on the number line. Move forward 30 minutes to reach 4 p.m. From 3:30 to 4 p.m. is 30 minutes. We need to find where 4 p.m. is on the number line. 4 p.m. should be 2 segments or ticks away from 3:30 p.m. since each tick represents 15 minutes. Okay. Now use SMP 3, 4, 5, and 6. Actually, let's go look at that. Let's do constructive variable argument only. Because now you get kids to talk about the SMP. Why is this happening? What's happening to the structure? What can we do as educators? What can students talk to their peers about? Paul started reading 3 p.m., read for 45 minutes. We need to find out where 4 p.m. is on the number line. Now it says break down the time intervals. Like they could do that for every one of the time intervals. And I'm trying to see if it does that. Ask students to explain their thinking out loud. Like when students talk to their neighbors, they are increasing their dendrites in their brain. They're creating more brain cells. They are, and synapses, like, and they're listening to what the answers are from their peers. Me explaining it as an adult is way different than a student talking about it. Could they argue the wrong answers? Why not? Could they argue the wrong answers? And forgive me because for some reason it is really hot in my house. Oh, because that's all right. You could get them to struggle through the other ones to find out why the other ones are wrong. We could do this for every one of these. So just as a recap, we want students, and I started out with overarching, the umbrella model. Routines for Reasoning is the book. I believe it's on page 3 or 4 of the book. Like, you could read that only. Make sense of the problem and persevere in solving them. I'll put the link in my description if you can't find it, but you could Google it. It's Routines for Reasoning. And then the next thing you want kids to do is to choose an avenue. Whether this avenue is quantities and relationships for MP2, mathematical practice 2, reason abstractly and quantitatively, and then structure, like look for a make sense of structure. They could do that. They could also use this avenue, look for and express regularity and repeated reasoning. You should be teaching all of these. And if you're a principal and you're like, ooh, I need to provide professional development, you could create the professional development. You could have them watch this video too. And then teaching each one of these separately. How could you model the math? How can you use what appropriate tools? You could have a big old line graph. Like, you could have them create this. You can create a human line graph within groups, making sure you have the right amount of number of students for each interval on the number line. And knowing that intervals are equal distance, like what's the language of the discipline, things like that. And then let's go back to it, and then attend to precision. This one, they have to do that. They really need to do that. You could use the same problem for a few weeks. You could argue you could add some English language standards too. I could argue that. But if you get your students doing this, it is going to change what they do academically. It's going to change how they are ready for the next school year. And if you're thinking, oh, I don't care about the state assessment, I understand. But you as educators took a basic skills test to teach. You may have taken the GRE. If you are in any type of arena and you had to take a professional exam, I don't know what doctor I don't want to take that exam. I wanted them to take that exam and I wanted them to do well. I want it. It can give students anxiety. It makes them anxious. But if we let them know that we just want to know what you know so we can help you. We're just trying, you're not being graded on that summative assessment at the end of the year. We just want to know what we can do to help you become better. So all of these tips and tricks will be in the description. The video has to continue uploading. Once that's there, I'll put a link in there, fill out the form, and you'll get all of my resources that I created regarding the standards for mathematical practices. So thank you so much for watching. I definitely appreciate you hanging out with me live this Saturday morning. If you have questions or comments, please share in the feed. Make sure you subscribe. And I'm talking about ChatGPT in December. And I feel like I need to go and find what day that is. So in December, let's go. I'm doing a webinar. It's free. It's just, I'm doing this for educators, but you can come even if you're not in education. It's December 7th at 7 a.m. You can register. I'll put the link in my bio. It's not my bio, in the description, so that you can join me as well. So thank you so much. Have a great Saturday, and I will see you next time, next Saturday morning, typically between 6:30 and 7 a.m. Pacific time. And that would be 8:30 to 9 a.m. Central time. Have a